Good evening, everybody. Can you hear me?
Yes, sir. Good evening.
Good evening.
1 second. Just give me a minute. Switch off your videos. It's not responding. Can you switch off your videos? Somebody with the name. Okay. Right. Can you guys see my screen?
Yes.
Okay. Right. Good evening, everybody. Again. My name is P. Nageshwar Rao. You can call me Nagesh. This demo class is organized by containerization. Go on mute if you're not talking. Go on mute.
Anda. Lakshika.
Okay. So this demo come first class is introduced by is organized by faculty.com. My name is P. Nageshwar Rao. I have totally 17 years of experience as a DevOps engineer. I'm a DevOps consultant and architect. My last company was Walmart Labs. Walmart, Flipkart acquired Walmart. I was the first person to join in Walmart as a DevOps engineer, 2014. That was my last company. And I got a chance to build a DevOps team with 14, 15 members. DevOps is one of the biggest online e-commerce platform based out of US. That's about me. And I've been training DevOps from last, say, 10 years. I do a lot of online trainings, a lot of classroom trainings, and a lot of corporate trainings as well. I would have trained more than 20,000 plus students in DevOps in the last 9-10 years. And I would have placements. That's the placement record I have. Today, what I'll do, since it's a demo class, demo come first class, I'll walk you through the tools that we have in DevOps first. What tools you are going to learn in DevOps, what tools are latest, and then what tools are required for you to get into IT job, to crack the interview, and then to survive in real time. And I'll walk you through each and every tool, taking a real-time example. So by end of today's demo, if anybody asks you, okay, what is Git, what is DevOps, you should be able to tell, you should be able to explain them at least in one sentence at a very high level. What is Git? What is DevOps? Understanding part, you leave on me. Just focus on the slide, okay? If you have any questions, you can unmute yourself at any point of time. You can unmute and then you can stop me and I'll clear your questions, okay? So as part of DevOps, these are the tools we have. First of all, I'll start the DevOps with Linux basics, because in real time, most of the times, 90-95% of the cases will be working on Linux operating systems. So you should have strong knowledge in Linux. I start from Linux basics, then take it to the intermediate level, then take it to the advanced level. By end of the course, you will become expert in Linux. So I'll start with the Linux basics. And for you to start DevOps, you don't need to have any prerequisites, right? You just join me with the empty minds. I'll take care of everything. You don't need to know anything to start this course. Whatever is required, basics are required. All those basics are covered here, okay? So let's start with the Linux basics first. Then we start with a tool called Git. Git is called as source code management tool. We'll go with the Maven. Maven is called as a build tool. Maven is called as build tool. Don't worry about what is build, what is source code management tool. When we deep dive into these tools, you will understand what is this tool and then where we use this tool in DevOps, okay? Then we have something called Jenkins. Jenkins is called as a CI/CD tool, continuous integration, continuous delivery, or deployment. Again, don't focus on the terminology. You will understand all these things in a minute. Then we will learn something called Docker. Docker is called as a containerization tool. Then we have something called Kubernetes. Kubernetes is trending and then emerging technology now. By just having expert knowledge in Kubernetes, you can get into DevOps with a very good package. Kubernetes is latest in DevOps. Kubernetes is called as an orchestration tool for containers. Again, don't worry about what is Docker, what is orchestration tool and things like that. Then we'll also learn something called Ansible. Ansible is a configuration management tool. Then we'll be learning something called Terraform. Terraform is infrastructure provisioning tool. And then we'll learn some cloud. When I say DevOps, it is actually AWS DevOps. What is this? AWS DevOps. DevOps with AWS. DevOps with some cloud. AWS DevOps. People call sometimes Azure DevOps, GCP DevOps, and things like that. Don't worry about this. I'll explain what is the difference between DevOps and AWS DevOps later. Okay. For now, let me just call it as DevOps. And as part of this course, you will also get one complimentary free course called Shell Scripting. So you'll get 20 hours recording sessions. It's a complimentary. Shell Scripting is a separate course. Sometimes for new batches, we give some complimentary courses along with DevOps, like Python recording classes, Shell Scripting, and things like that. There are a lot of other tools, miscellaneous tools like Tomcat, Jira, and things like that. I'm not listing those tools here. There's something called DevSecOps. What is that? DevSecOps. DevOps with security. It's like, again, a buzzword in Can you hear me now?
Yes, sir.
Yes.
Yes.
Audible, sir.
There was some network fluctuation from my side. It's happening from the evening. Please bear with me. Okay.
Yeah, but presentation is not visible, Nagesh.
Sorry, yeah, 1 second. Can you see the screen now?
Yeah, we can able to.
Okay.
Yes,
So
sir.
these are the tools you will be learning as part of DevOps. Okay. People sometimes come to me and they say, sir, DevOps is DevOps difficult? DevOps is difficult because you have to learn a lot of tools. The tools list is very long, but these tools are very small and then tiny tools. You don't need to write, you don't need to do any programming. All these tools are command line oriented tools. Small tools you can learn very easily. Don't worry about learning part. What I'll do now to make you better understand what these tools are, what is Git, what is Maven, what Jenkins. If I just explain, you don't understand. Let us apply these tools on some real-time project called Flipkart. Everybody knows Flipkart. Flipkart is online e-commerce platform, right?
Yeah.
Before I explain what these tools are, I just want to understand why you have to take DevOps in faculty, right? What is that you are going to learn? How you are going to learn? In faculty DevOps course, right? As I mentioned, I have 17 plus years of experience in technology, right? I'm a DevOps consultant and architect. I would have trained more than 20,000 students and then placed 8 to 10,000 students. That's a placement record I have. Whatever I teach in DevOps, I start from very basics first, because 90% of students in my class are people who are from non-IT background. People say, I'm 2018 pass out, 19 pass out, civil, mechanical, or some MCOM, BCom, computers and things like that. They say, I want to get into DevOps. I want to get into IT. I want to transition my career from non-technical to technical, non-technical to IT. What should I do? 90% of my students belong to that category. There are 10% of the students who are already working in DevOps. They want to upskill themselves. They come here. So this is the teaching framework I follow. I first teach you the concept. Any topic I touch, this is how I teach. First, I teach you the concept, theory. Once you understand theory, concept properly, then we'll be doing practicals. Practically, I'll explain that concept again. Once you are thorough with practicals, then we'll be applying those practicals on some real-time projects. As part of this course, you'll be working on 3 real-time projects. capstone real-time kind of projects. If you work on these 3 projects, you can very easily survive in real time. My students, after completion of the course, they claim almost 3.6, 4.2 years of experience, and then they get the job. They crack the interview on their own, and then they survive very easily. I'm not telling this based on 1-2 students, based on 8 to 10,000 placements that I have done from last 8 to 10 years, right? So if you work on these 3 real-time projects, 3-4 in fact, real-time projects, you will get the knowledge which is equal to 3-4 years real-time experience. If I'm teaching, for example, Python, Java, I don't dare to claim myself that, you can work in real time with 3-4 years experience, because programming, you cannot learn over the night. Since it's a DevOps, a lot of concepts, coordination is involved, right? All are command and oriented tools. You can very easily work with 3-4 years real-time experience, because we'll be working on 3 projects. So I'll first teach you the concept, then we'll be practically executing all those things in the classroom. Then I'll give the practical notes to you, soft copies and different material. After completion of the class, you keep these notes in front of you, and then you can practice on your own. So concepts, practicals, then we'll be applying those practicals on projects. Then we'll be discussing a lot of interview questions. Assume that I'm teaching on concept today. I'll teach, interview questions also at the same time. Like, for example, you take a topic, there may be 10-15 questions related to the topic. I will tell you, okay, so these are the interview questions you can expect, on this particular topic. This is the question, this is how you have to answer. We'll discuss about interview questions and then best practices and things like that. Any topic I take, I'll follow this teaching methodology. It's a 10 years real-time experience, right? So understanding part, just leave it on me. You just need to focus on your practice, that's all. If you just practice, if you just follow my guidance, whatever I explain in the classroom, you can very easily crack the interviews, right? Okay. That's about the training framework, how I teach. See, there may be more knowledgeable DevOps people than me, correct? But when it comes to the teaching, how you simplify, how trainer simplifies the topic is what matters, correct? Since 90% of the students are from non-technical background, I have to get down to your level first. I have to start from very basics and then take it to the advanced level. After completion of the demo, you will understand, my teaching, style, right? So you'll get that idea. So with this, let's get started with, Git first, okay? Or let's get started with Maven first. So what I'll do, I'll take one real-time project called Flipkart. What is this? Flipkart, okay? You all know Flipkart, right? Assume that Flipkart has 100 developers. 100 developers. What do developers do? Developers write code for application, correct? Developers write code for the application either in Java, C, C++, .NET, and so on. Assume that Flipkart is developed in Java. Okay. There is a misconception. When I say DevOps, a lot of people say, I don't know coding. I have phobia about coding. Do I need to work like a developer? No. Here, dev doesn't mean that you are a developer. Here, dev means it's different. You'll understand that later. So you take a Flipkart. Assume that Flipkart has 100 developers, correct? Developer's job is writing code for the application, correct? There is a developer in Flipkart. This guy is a developer. This developer writes code in Java, right? Correct? Assume that this developer is writing the code for creating a login button. You take any website, there is a login button, correct? To create this login button, somebody has to write the code, right? So this developer is writing Java code to create this login button. Let's call it as login.java. Java code always ends with .java. Like you have .txt, .xml and things like that. Java code always ends with .java. And who is writing this Java code? It's a developer, not DevOps. So this guy writes code something like this: button bt is equal to new button, bt dot create, bt dot name, login, something like this. It's a pseudo code. Okay, we are not developers, right? We don't write Java code, so don't worry about this code. So you execute this particular Java code. This code has to generate what? Login button as an output, correct? So to create the login button, developers write code something like this. So expectation here is once I execute this Java code, this file, it has to create a login button for me, correct? But there is a problem here. What's that? We cannot directly execute Java code. We cannot directly execute Java code. Why? Because machines don't understand this Java code. This is in plain text, right? B, U, T, T, O, N. Machines don't understand what is B, what is U, what is T. Machines don't understand plain text. What language machines understand? Binary, zeros and ones, correct? So machines understand ones and zeros. If you write the code something like this and execute, machines cannot understand. So machines understand only binary code, correct? You call this as binary code or executable. What do you call this? Binary code or executable. So you have to write code in binary language. For example, I have to write something like this. C is equal to 10 plus 12. Machines don't understand what is 10, what is 12, what is plus, correct? You have to write this in binary, correct? How do you write this in binary? For example, 8, 4, 2, 1. 8 plus 2, 10, 0, 0. 10 equivalent binary is 1, 0, 1, 0. 8 plus 4, 12, 0, 0. 1, 1, 0, 0. That's a binary equivalent of 12. See how difficult it is for us to write the code in binary. Is it possible for any human to write the code in ones and zeros? No. So there is a problem here. What is the problem? We write the code in our own understandable format, that is plain text. Machines don't understand. Whatever machine understand, that's difficult for us to write, correct? So how do you bridge this gap? That's a question. You lost the screen. Can you hear me now?
Yeah, okay.
Yes, we can hear.
Did you see this line before when I drawn? I just want to understand where it was stopped. Did you hear previously when I
No,
wrote
we
this
didn't.
compile?
No.
Okay. So we write the program in our own understandable language, that is plain text. Machines don't understand. Machines understand only ones and zeros. Whatever machines understand, we cannot write the code. That's the reason what we do. Once developers write the program in .java, we have to compile it. Okay. Very simple, I'll tell you. You are a developer. You write the program in Java. You have to execute and then it has to generate a login button. But you cannot execute .java. You have to write the program in binary. You cannot write. It's very difficult. That's the reason we have to bridge this gap. So that's the reason what we do. Once developers write the program, we compile it using somebody called compiler. There are some compilers. You compile this .java. This compiler checks the language syntax, grammar rules, and everything. If this .java syntax is correct, you know what it will do? It will generate equivalent binary for us. Assume that developer has written 100 lines of code. Once you compile, this compiler generates 100 lines of code, which is binary, which is machine understandable code. You're writing .java, compile it. Compiler is helping us to generate machine understandable code, that is binary. Problem is solved now. So you write program in your own understandable language, compile it, you get a code which is machine understandable. Simple. So once you compile this login.java, this will create another file called login.class. We write .java, compiler generates class file for us. Class file is for the machines, right? Java is what we write. Class is binary equivalent of .java. And then once you generate this particular file, you execute this on some operating system, you get the output. So what is the summary here? Whenever our developers write programs in Java, somebody has to compile. Without compiling, can you get the output? Can you execute the code? No. Correct? Right. This is happening with, say, we are talking about only one .java file. If you go to Flipkart, you will see somewhere around 10,000 to 20,000 .java files. How many .java files? 10-20,000 .java files you see in Flipkart. Until and unless you compile all these 10-20,000 .java files, can you execute the code and then see Flipkart application? No, correct? We have to compile all these 10-20,000 .java files, right? So question comes, how do you compile 10-20,000 .java files? Manually? Is it possible for you to compile each and every .java file manually one by one, 10-20,000 files? Very difficult, correct? It is time-taking process. Any manual activity is time-taking process, and it is error-prone too, meaning there is no guarantee that you will be able to compile all these 10-20,000 .java files without missing something, correct? Right? So that's where in software, what we do, we try to automate when there is some manual activity. If you want to automate, you need a tool, right? You need a tool. So here, there is a tool called Maven. What is the tool name? Maven. If you have Maven tool, you can compile thousands of .java files very easily. So Maven is called as a build tool. Just give this 10-20,000 to Maven, right? 10-20,000 files to Maven. Maven can generate 10-20,000 .class files, binary equivalent code for us very easily. What is the tool we have here? Maven. To take a general English meaning of a tool. For example, you have to produce 1,000 bread packets, 1,000 bread pieces, for example. How much time it will take if you want to make 1,000 bread pieces manually? It will take a lot of time, correct? So you would have seen some machinery online, correct? So you have a machinery. Machinery means tools you have. You just pour, water, sugar, atta at one end. The other, that will go through different machineries. At the other end, you will see breads coming out, correct? That's called as what? Automation, correct? Same thing we apply in software also. So here, what is the manual activity we have? Compiling 10-20,000 .java files. It's very difficult to compile all these things manually. So we have a tool called Maven. Just feed these 10-20,000 files to Maven. Maven can compile all of them and then generate mission equivalent code for us. So Maven is called as build tool. It is building binaries from .java files. This is called as source code. What do you call this? Source. This is source and this is binary. Source means whatever we write directly. Source code. So just feed this source code, Maven. Think Maven as a person. Just give these files to Maven. Maven can compile all of them very easily for us. So what we are doing here, using Maven tool, we are automating code using Maven, we are automating code compilation process. Understand what is Maven? Maven is a build tool. Using Maven, we can automate code compilation process. Correct? Okay. Again, we don't manually go and then execute some Maven command. We can schedule it, right? Go and then compile the code at this time. It will go and then automatically compile the code for us. We can do that as well. Yeah. Right. So Maven is a build tool using which we can compile the code. Why we have to compile the code? Without compiling, we cannot execute the code. Correct? Let's integrate Maven with Git now. This is your Flipkart development team. Flipkart. How many developers Flipkart has? Say 100 people. these developers write the code in their local laptops or desktops, correct? Developers write the code in their local laptops or desktops. Once they write the code in their local laptops or desktop, they go and then place their code in something called Git. What is that? Git tool. GAT Git. So for example, there is a developer, right? Developer wrote some code in his or her laptop. 100 developers have the code in their laptops, correct? End of the day, we have to collect all this developers code at one place, correct? So this is the place, Git. That means you take another mission. In this mission, there is somebody sitting here. Who is that guy? Git. That means you have to install a Git tool. And then in this Git, there is something called repository. What is that? Repository. Think repository as a folder. Repository as a folder. Think it as a folder. You take a mission, you install a tool called Git, you create a folder here. Folder, or you call it as a repository. So all these developers, once they write the code in their local laptops, they all connect to this Git server. They place their code here. So end of the day, we have complete Flipkart application code we have in Git. This is mission 1, say for example. This is mission 2. So we are all 100 developers. We write the code in our laptops. We connect to this Git using some commands, and then we upload the files from our laptop to this Git. They push it. That means they upload the code from their laptops to Git. Yeah. For example, a new developer joins in Flipkart developer. What this developer will do? If the developer has to write the code, the developer has to first take the existing code, correct? He will use a command, hello Git, please clone the code from this repository. Git clone, and then they'll give this server name. The moment the developer executes Git clone and server name, existing code will be downloaded in his mission. He will add some new files, he'll modify the code and things like that using some, for example, Git push. If the developer runs Git push command, the code will be uploaded to Git. Again, another developer takes the code, modifies the code in his or her laptop. Again, they will upload the code to Git. That's how developers collaborate with each other. So end of the day, all developers code, complete Flipkart application code is in Git. Think this as a folder. In the folder, you have complete application code. Storage, yeah. In simple words, think that, okay, complete application code is stored in Git, right? Okay. I'm just using a simple terminology so that you understand better. I'm not complicating the things because it's a demo, right? The purpose of demo is you need to understand what DevOps is, what a particular tool is at a very high level. That's the plan. Every day, these developers write the code in their laptops. Every day they place the code in Git for developing new features, for bug fix and things like that. Every day, DevOps engineers clone the code or download the code in another mission. This guy is DevOps. DevOps engineer, you. So once developers write the code, once they place the code here in Git, as a DevOps engineer, we download the code. This is DevOps engineer's laptop, say for example. So when we when we clone the code, when we download the code, whatever code we have in Git, everything comes here, correct? For example, in this Git, you have source code, right? Yeah. This is source code, right? Source code can be anything. There may be some .java files because developers write Java code, right? So in this Git repository or in the Git, you have maybe say 10,000 .java files. There may be some XML files. There may be some CSS. There may be some say TXT files. There may be some images and so on. So complete application code is in Git. So you don't worry about what you have in this Git. This is not our job, right? Developers write this code, Java, CSS, XML, HTML, and things like that. So there are some HTML files also. Okay, right. At the end of the session, I'll explain how you can transition your career from non-IT to IT. Just wait for that, okay? So as a DevOps engineer, every day they place the code in Git. Every day we take the code in our mission. So once we clone the code, what do we get here? Whatever we have in Git, same thing comes in our laptop, correct? we download the code. So assume that you have some .java files, you have some HTML, you have some CSS, some JavaScript, some images, and so on. So once we download the code, guess what we do? Once we download the code, what we do? We have to compile the code, correct? Assume that you have 10,000 .java files. When we download, we'll get 10,000 .java files here. Once we get 10,000 .java files, we compile all these 10,000 .java files, and then we have to generate 10,000 class files. We have just discussed, right? Without compiling, can you export the code? No. So developer's job is developing the application code. DevOps in his job is automating that compilation process. We compile the code. Using what? Manually? No, right? We use a tool called Maven. So we are experts in configuring Maven tool so that it compiles thousands of .java files. That's what we do. Okay. In order to run application, apart from this Java code, we need a lot of other files also. To run the application, we need to have some, say for example, we need some HTML files. You have some HTML files here. I can say that you have 100 HTML files. Whatever HTML files are required, we copy that here. Assume that you have some images. Whatever images are required for application, we copy that in this folder. Say maybe some CSS files and things like that. After compilation. So what we're doing here, we are downloading the code, we are compiling the code, generating machine understandable code, 10,000 .java files, 10,000 class files, and then whatever other resources, other files are required, we are separating everything in this folder. Again, what files are required to run the application, we don't know as a DevOps engineer. Developers will tell us what files they need. We call this process as build process. What is that? Build. Build means compiling the .java files and then generating class files, building class files, plus separating the files which are required for application to run, like HTML, CSS, and so on. We call that as build process. I am building binaries from source code. I am building application from source. Now you understand why we call it a source. This is just a source. Can you launch application? Can you execute this code? No. Somebody has to take it and then convert that as, transform that as binary. Then only you can execute the application. If you have this folder, if you have this code, you can launch application from that. So we call this process as what? Build. Build means converting the source code into binary, plus separating other files which are required for application to run. Sorry? We don't know what files are required. In Maven, developers write some code. If you just, our job is to just execute the code. If you execute Maven code, that will compile and then separate the files. All those things are configured in Maven. Developers will do that. Right? So we just need to execute one command, Maven command. For example, min install. It will compile and then it will separate the files. And Maven has some configuration files and it knows what needs to be placed in this folder. Yeah. We'll be learning all that stuff later, right? When we work on projects, we have projects like Flipkart project, we have other projects. Okay. So when we execute those projects, we'll be literally taking some project code. We will be building it and then we'll be generating all this things. Okay. Right. So what do you call this? Build. Earlier, DevOps used to be called as build and release engineer. 15, 17 years back, when I started my career, I started my career as a build and release engineer. Build and release engineer. What we do, we build the applications, correct? We build the applications. This is the source. I'll tell you a simple analogy. Say you take a construction company, right? You have sand, you have bricks, you have some steel and things like that. That's a source. Somebody will take this source, shape that brick metal into different shapes, and then you'll get the final product, correct? Here in software, what we are doing, we are taking the source, Java, we are converting it as a binary. So this is source, this is binary. We are building a product. This is the final software. When I joined as a build and release engineer, I went to my native. People ask me, okay, what's your designation? I heard that you got into software. I said, my designation is build and release engineer. The moment I said build, they said, do you build bridges, Apartments. I said, that's a civil engineer's job. I said, I build softwares. Correct? So we are taking this and then we are building the software. So once you have this built code that is binary, you know what we do? We take this particular code and then we copy this into something called Tomcat server. What is that? Tomcat server. Okay. We call this as deployment. What do you call this? Deployment. See this. First step is what? Download the code. Second step, using Maven, somehow you create this binary and then paste. Once you have this folder, we compress it and we create something called flipkart.var. var means web archive. Think it is a zip file. Where is a zip file? You have something in a folder, you right click and then say create a zip. It will create a zip, right? If you extract, then again you will get the code. So what is this file name called? var, web archive. It is like a zip. For now, think it is a zip file. So once this zip file is created, var file is created, then we copy that particular var file into another mission called Tomcat server. This is your flipkart.var. What is there in this? Mainly your Java code, compiled code, mission executable code. You have some images, you have some HTML, CSS, and so on. Correct? Right. Once you build the var file, then we copy this particular var file into Tomcat server. Copying the var file into Tomcat server is called as deployment. So this is developers mission 1. In mission 2, we have complete application code. In mission 3, what we are doing? We are compiling and then what is the final goal here? Creating the var file. Mission 3. In mission 4, we are copying this code. 1, 2, 3, 4 missions are involved here.
What do we have to add? So the developer. If they need external adding ways to be developers will tell you.
Yeah. So assume that developer is writing new code, for example, to develop a feature, 10 new files.
Because in team, there's a both developers over there, DevOps also there.
Correct.
And testers also there.
Yes.
Both those communicating each other.
Developers, DevOps, testers work very closely. You'll understand. Just give me a minute. I'll explain that. So once you develop once you build the var file, we'll have to copy that var file into Tomcat server. We call it the build and deployment. This is a mission, right? This is again a server, right? Server means a mission. Name of this mission is flipkart.com. What's the name of this mission? Flipkart.com. A mission has an IP address. This mission has a name. What's the name of that mission? Flipkart.com. So once the build and deployment is done, anybody in the world can access the application now. Assume that this guy is, say, end user. How do users access Flipkart application? They type www.flipkart.com. So once user types flipkart.com in the browser, what happens? No matter where the user is, where this Tomcat server is, this browser connects to this mission using internet. In this mission, there is somebody, right? Who is that guy? Tomcat server is running. This guy has a code. So this Tomcat server executes the class files. Now class file is a mission executable, right? It's a binary, correct? So the server executes the code and then it sends a response back to the browser. You will see Flipkart homepage here. Assume that you have images also here. Class files, Java code is executed in the server. You have some images here. So it will forward those images to the browser. And you will see Flipkart homepage with browsers and things like that. Now, do you understand how developers code is becoming as an application? Yeah. Correct? Developers write the code, they place the code in Git. As a DevOps engineer, we take the code, we compile the code, we build the code, we deploy the code in the server, then only real user can access the application. Then only real user can access the application. Take Facebook.com. Facebook developers write the code. Facebook code is placed in Git. Facebook DevOps engineers clone the code. They build the code, they place the code in Tomcat server, then only we are able to access Facebook.com. Tomcat is a server, it executes the code. Sorry? Tomcat is only for the web-based application. See this? web-based applications work based on client-server model, in the sense there should be a server. There is a server. In the server, what is there? Code is there, your var file, class files or whatever. This is your browser. Browser is called as client. The moment you type flipkart.com, www.flipkart.com in the browser, you are typing flipkart.com means the flipkart.com is a server name. Flipkart.com, that's a server name, okay? That's the name of the machine. This is called, your browser is called the client. Client sends a request to the server. What is the server name? Flipkart.com. Client job is to send a request. Server job is to process the request. In the sense, the moment you say flipkart.com, that means you are asking for flipkart.com homepage to server. So it will come here, server executes the code, and then it sends response back to the browser. You will get the homepage. So this is the client, this is the server. Gmail.com. Gmail.com code is here. The moment you type gmail.com, it will come to this server, Tomcat server. Tomcat server executes the Gmail application code, and then it sends response back to the browser. You will see all your Gmail homepage here. So any web application you take. Web application means which works based on internet. Without internet, you cannot access flipkart.com or gmail.com, right? So Tomcat server is required for any web application. Is that clear? Okay. So here again, do you, as a DevOps need, do we manually download the code, execute Maven, copy this manually? No, we automate this process. Even though you are not in office. Assume that developer writes some code at 2 a.m. and then there is a new code in Git midnight 2 a.m. Even though we are not there, our automation will automatically, the moment there is a new code, our automation will take the code, it will build the code, it will deploy the code, it will also send email to the development teams and testing teams saying, okay, build and deployment is done. Now you can access your application or do testing. We automate that way. We are also automation engineers. I'll explain more on that later. Okay. Do you understand what is Git and then what is Maven now?
Yeah.
Git is the place where we store complete application code. Maven, using Maven, we build the code. Correct? Okay. Any questions you have before I explain what is Jenkins? Any questions you have? Do you understand what is Git, what is Maven? Build and deployment, end-to-end workflow. You understand how developers write the code. See, once developers write the code, if you don't do this build and deployment process, end users don't have application. We have to build and deploy the code, then only end users access the application. Any questions you have so far? Hope you can unmute yourself. Are you able to unmute yourself? Can somebody speak?
Yes, we have a real-time
Yes, yes.
Yes, sir.
Okay, fine. See this. Now, assume that we have built the code and then we are deploying the code, right? Do you deploy the code? That means, do you copy this war file every day to the production? Flipkart.com means it's a production. Production means where live users are connected. The real, this is called the environment, production environment. That means Flipkart.com is a production environment where live users are connected. The moment developers write the code, we take the code, we build the code. Do we directly deploy the code in the production? No. We don't directly deploy the code in the production. Why? We have to test it, correct? So we don't every day deploy the code into production. Instead, you know what we do? We deploy this particular var file into a test environment where that means I take a separate mission. Name of this mission is flipkart-qa.com. Or let me call it as flipkart-test.com. What is the name of this mission? Flipkart-test.com. What is the name of this mission? Flipkart.com. So every day developers write the code. Every day they place the code in Git. Every day I take the code, build this particular var file. I copy that var file into where? Another mission called flipkart-test.com. Then comes my testing team. Testing team says flipkart-test.com. When they say flipkart-test.com, where it will go? The browser will connect to this mission, correct? In this mission, what you have? Latest code, correct? Assume that developer is developing some feature, cache and delivery feature. He writes 10 Java files. You take 10 Java files, compile it, and then you have 10 Java files which are related to cache and delivery feature. So when this guy accesses the application, he will see cache and delivery feature, cache and delivery in browser. So that's how testers test the application. So every day, we will be deploying the code into test environment. This is called the test environment. This is called as production, where real users are connected. And then they will access the application. They do testing every day. Assume that there is a bug in the code. Testers will inform that issue to the developer. Developers again modify the code. Again, there is a new code here. Again, we take the code. Again, we build it. Again, we have the new code here. Again, they test it. So every day, multiple times, we'll be building the code. We'll be deploying the code into test environments first. We work like this for a week, for a month, for 2 months. Once testing is done, one day, once testing team say that, okay, there are no bugs in this application, then we will copy the same WAR file into production. And our real users get new features. That's how DevOps engineers work with developers and then testers. We work very closely with these two teams. For example, we are taking the code, we are compiling the code here, correct? Using Maven. Assume that there is some compilation error. There is some error in the code. What do we do? Do we need to fix that error? Are we developers? No. What do? We report that development, we report that compilation issue to the developer. They fix it again. Again, they fix it. They place the code here. Again, we take the code. So we are very closely working with the developers. Assume that this guy is a tester. This guy is accessing the application using flipkart-test.com. There is some error here. Okay, sorry. So this guy is accessing flipkart-test.com in the browser, and he's unable to access the application in the browser. What do? They'll come to DevOps engineer. Hello, DevOps engineer. I'm typing flipkart-test.com. I cannot access the application. Since I cannot access the application, I'm unable to do the testing. Please help me to bring this environment up. What do we do as a DevOps engineer? We are only deploying the code, right? So we go and then check whether the right code is deployed or not, whether the Tomcat server is running in this machine or not, whether there is enough CPU, RAM, storage, and things like that. And then we'll make sure that flipkart-test.com is always working. Likewise, we'll be having multiple environments also sometimes. Say there is a manual testing team or automation testing team. So these teams access the application. We take the same WAR file and then we deploy the code into another mission. We call it as flipkart- say for example, sit.com. So there is another testing team. SIT means system integration testing. Don't remember all these words. Just remember that there is some other testing team. These people talk to access the application from this environment. System integration testing.com. They do system integration testing. So likewise, we will be deploying the WAR file into multiple environments. As a DevOps engineer, our job is to make sure that deployments are happening in all this test environment, plus all these test environments are up and running. If these test environments are not up and running, testers cannot test the application, right? And also, we have to make sure that flipkart.com is always up and running. See the responsibility of DevOps engineers. DevOps is very niche in software. It's an emerging and then a trending technology, or we call it a process. That's the reason people are transitioning their career. In fact, even working people also, like people working in testing, people working in mainframes, people working in Tableau, ClickView, people who are working in some dying technologies, right? Who think that their career is not progressing well, who think that they are not drawing enough salaries and things like that. These people are moving their career to DevOps because it's a emerging and it's very niche. Hardly 50 to 60% of the companies have adopted DevOps. That means 50 to 60% of the applications are using these tools. Remaining companies are not using few tools. So they are in the process of implementing these tools. That's the reason there are huge job opportunities in DevOps. Since it's a niche, DevOps engineers get more salaries or better salaries than developers and testers sometimes, or most of the times. Okay. So our job is to make sure that test environments and production environment are always up and running with our automation. Clear with this? There is something called production. There is something called test environment. So every day we deploy the code to test environment, we test it, and after 1 week or 2 month, once bugs are fixed, then we deploy the same code to the production. Clear with that? Okay. Here, there are 3 manual steps are involved. Again, you have to download the code first step. Then you have to execute Maven for compilation, correct? Then you have to copy this into this. Let me integrate this Git Maven in another tool called Jenkins. Jenkins. There's a tool called Jenkins here. Let me see why we use this Jenkins here. See this? Assume that this is your Jenkins. Jenkins server. That means you have a machine here. Correct? You have a machine. Name of this machine is Jenkins. Jenkins is a browser-based tool. It's a GUI browser-based tool. You know what we do in the Jenkins? Once we install Jenkins in this machine, we launch Jenkins in the browser. Here, we create something called a project. What is that? Project. Or you call it a job, or you call it the pipeline. Very simple. You have installed Jenkins in this machine, correct? And you are integrating your Git, Maven, your deployment commands, and then schedule and things like that. So you launch Jenkins in the browser. You create something called project. In this project, it's like, you launch Jenkins in the browser. It'll ask you, give me the Git URL. That means any Git server you take, that will have some URL. Okay. You give me your Maven command, which will compile the code. You give me deployment command, which will copy the code in Tomcat server. So all those things we are integrating in one place, that is Jenkins. And then you just execute this. If you execute this, what will happen? Jenkins, it knows where is the code, right? The moment you execute this project, it will go to Git. It will clone the code. Then it will do what? It will execute this Maven command. Then it will deploy the code into Tomcat server. So it will automatically execute this download, build, and deployment process for us. You don't need to manually execute these 3 things in 3 steps. Clear with that? For example, you can also configure Jenkins in such a way that Jenkins, right? It will talk to Git for every 5 minutes automatically. It will go to Git. It will ask Git, hello Git, do you have any new code? Git says, I don't have any new code. It will come back. Assume that developer commits something at 2 a.m. Developer committed something at 2 a.m. Developers wants to test his or her code. If developer wants to test the code, what has to be done? Developer is working midnight. Developer pushed some new code. If developer wants to test this code, what has to be done? Somebody has to take this code, build the code, and then place the code here. Then only developer can say flipkart-test.com and then access the application and then test it, correct? So who will build and deploy the code at 2 a.m.? Does that mean that we have to be awake whole night? No, right? See how we are automating. What we do, we bring something called Jenkins. In Jenkins, we give the Git server URL. We give the Maven command, whatever is compiling the code. We give the deployment command, which will copy the var file into this server. And then we'll also give a schedule, 5 minutes. So what will happen? Our Jenkins will talk to Git for every 5 minutes. There is no code, new code. It will come back. Again, after 5 minutes, it will go to Git. Hello, Git, do you have any new code? Git says, it's at 2 a.m. I have some new code. The moment there is a new code, Jenkins will automatically take the code. It will execute this Maven. It will build the code. It will deploy the code into this Tomcat server. It will also send the email in 2 a.m., for example, saying, okay, build and deployment is done. See the automation that we are doing. Without any manual intervention, we are able to build and deploy the code the moment there is a new code in Git. That's called as an automation. So what is the tool using which we are automatically we're automatically cloning, building, and deploying the code? Jenkins. We call that as a continuous integration tool. Continuous integration tool. When developers write the code, how you are integrating that code with existing code. That means how you are taking the code and then placing the code here. How you are integrating it. Continuous integration tool. So we call Jenkins as a CI/CD tool, continuous integration tool. So how do you define CI? What is continuous integration? Continuous integration means it's a process or a tool which will connect to Git. The moment there is a new code, it will take the code, it will build the code, it will deploy the code seamlessly without any manual intervention. It will execute this build and deployment process continuously for us without any manual intervention. So the automation, we call that as continuous integration, CI. Clear about functionality of Jenkins? Very simple. All these tools we bring in Jenkins and we tell Jenkins, okay, if there is a new code, execute this build and deployment process for it will automatically take care of continuous integration tool. CI/CD, continuous deployment. What is CD? You can also do this. See, for example, the moment there is a new code, Jenkins is automatically cloning the code, building the code, and deploying the code into test environment, right? This is your test environment, correct? What is the main goal? Once testing is done, we have to copy that code into the production also, right? Correct. Yeah. So what I do, once I push the code to test environment, I will execute some test cases. Here, I'll say, hello Jenkins, if 100% test cases are successful, copy that code into production. See the automation that we are doing. Developers write the code, there's a new code, Jenkins will take the code, build the code, copy the code here, it will run some automation test cases. If 100% test cases are successful, then it will automatically copy that code to the production. Without any manual intervention, we are pushing the code all the way from development to production automatically. See the automation that we are doing. You call this as CD. If you are continuously copying the code to the test environment, you call it as continuous integration. If you are pushing the code automatically to the production, you call that as CD, continuous delivery or deployment. Understand the CI/CD? Don't try to remember. It's a first class. It's a demo, right? Just remember, Jenkins will connect to Git. The moment there is a new code, it will clone, build, deploy to test environment. If everything is fine, then it will also deploy the code to the production. Deploying the code into test environment is called as a CI. Deploying the code into production is called as CD, continuous deployment. CI/CD tool.
Both will be using the Jenkins.
Yes, both we achieve using Jenkins. So as a DevOps engineer, we will learn Jenkins. That means we launch Jenkins, the browser, and then we should know where to give that Git URL, where to give that Maven command, which will compile the code. What is that command which will copy the WAR file into the environment, and then where to schedule that 5 minutes. You set alarm in your mobile, right? So in Jenkins, we should know how to set that 5 minutes trigger, for example. Correct? So as a DevOps engineer, we automate this using Jenkins. So in DevOps, right? Here, Dev means development and then QA. As a DevOps engineer, we are automating development and then QA related processes. What is that development and then QA related process here? See, the moment developers write the code, right? If we don't place the code here, they cannot test the application, right? They cannot launch the application from the browser. Even testers also cannot test the application. So Dev means development and then QA. Their Dev means we are automating development and then QA team's process. Dev. That's the meaning of Dev. It's not developer. Okay. Dev means whatever activities are involved during development and the testing, we are automating that. We are helping development and QA teams to achieve their tasks. Dev. Then comes ops. I'll explain that ops later. Understand what is Git? You go out now, your friend asks, how do you have attended the demo? Tell me what is Git? What is Git? Storage. A place where we store application code. Right? Why we store application code in one place? Because developers write the code in different laptops, right? 100 laptops. What is Maven? Build tool. Why we use Maven? For compilation. Your friend will ask you, what is compilation? Say, I write the code, correct? All that machine understands the ones and zeros. How machines understands even ones and zeros? How even Maven machine understands ones and zeros? You have seen the Robo movie, right? Right?
Yes, sir.
this is your, see, they said, there is some song, okay, I don't know how to convert this in English or whatever, right? So in Telugu, they say like Inamulo something. So it's like iron, right? It's a hardware, right? It's a hardware. Say for example, you have hardware means you have a memory chip. It's a hardware, correct? You would have heard about memory, right? You have diodes. I'm not an electronics expert, by the way. I'm assuming that it is stored in diode. For example, you have diode cells. What is the binary equivalent of 10? 8, 4, 2, 1, right? 8 plus 2, 10, 0, 0. What is the decimal binary equivalent of 10? 1, 0, 1, 0. This is how it stores 10. 1, 0, 1, 0. It will not store 1 because it doesn't know even what is 1, right? It will store a small amount of power here. Power is there means it's 1. There is no power. There is a power. There is no power. You can store power, right? Current, power. So it stores power means it will consider that as a 0. No power, power, no power. 10. What is the binary equivalent of 20, 12? 8, 4, 2, right? 1, 1, 0, 0. So again, 1 power, it stores a small amount of power, 0, 0, no power. So this is 12. So for computer, this is 10, this is 12. Now you say 10 plus 12, what it will do? It will send this information. Again, this is also hardware. Have you heard about logic gates, switching theory, right? It sends this information through another circuit, for example, hardware. This will add and then this will give some binary. 10 plus 12, 22. 22 equivalent decimal, binary, sorry. Then it will convert that and then to the decimal, it will show 22 on the screen. So it knows only ones and zeros. Even how it knows ones and zeros, small power is there means 1, no power, 0. See, it's iron, but we are able to get the things done from the iron computer. See the human knowledge. That's a hardware, right? Why this topic came now? Why this topic came? Sorry? How machine understands ones and zeros, right? So your friend is asking you, why we have to compile the code, boss? Whatever you write, machines don't understand. Understand ones and zeros. You have to give ones and zeros to machine. So there is a person called, there is something called compiler, and we cannot compile the code manually. There is a person called Maven. You just give 10, 20,000 Java files, throw 10, 20,000 Java files to Maven. Maven can generate ones and zeros for us. So Maven is a build tool. It is building the binaries from the Java source. What is Jenkins? My developers commit the code midnight. I don't have to be awake till midnight or hold. It's not possible for any human. So I automate it. So there is another person called Jenkins. I just tell Jenkins, this is my Git URL. This is the Maven command you have to execute. This is where you have to copy the war file. And this is the time, 5 minutes. Just give that information to Jenkins. Jenkins will go to Git. Every 5 minutes, it will poll. That means it will connect to the Git. The moment there is a new code, it will automatically clone, build, deploy the code. We call that as continuous integration. So Jenkins is helping me to achieve this. Can't you explain this in one sentence? Understand what is Git, what is Maven, what is Jenkins? So as a DevOps engineer, my job is to configure all these things. Developer's job is writing the code. My job is this. If I am not there, there is no application for testers to test the application. There is no application for end users. You are typing flipkart.com means in Flipkart office, there is a mission. Flipkart developer, DevOps is compile the code, deploy the code in flipkart.com. Then only you are able to access flipkart.com. We build the applications. If DevOps engineers are not there, then end users cannot access the application. It is DevOps engineer who makes the code as an application by doing this build and deployment. Understand this? Okay. DevOps. Dev means development and then QA. So we are automating something. We are helping development and the QA teams to automate something that is build and deployment process. Clear with this? Any questions you have so far? I need another half an hour time. Shall we continue?
Yes, please, sir.
Yes.
Okay.
Okay. See, ops part is very interesting. DevOps. Nothing great about this. This is very important, and then very challenging in real time. I'm sure you will definitely enjoy what this Docker Kubernetes and how Docker Kubernetes helps Flipkart. Now, do you understand how Git, Maven, and Jenkins are helping Flipkart project, Flipkart company? Right? I'm not just explaining the tool, right? We are applying these tools in a real-time project. If Jenkins is not there, what will happen? Developer, writes the code, commits the code, pushes the code to Git. He has to wait till morning, say 9 a.m. or 10 a.m. until DevOps engineer come and then deploy the code. Then only he or she can test it. Correct? Or company has to pay DevOps to be awake whole night. It's not possible. There are a lot of things. Okay. Now let me explain where this cloud comes in picture. Right? Where this cloud comes in picture. What is that Ansible? What is the Terraform? Which is very interesting. See this. So, in real time, do you think there will be only one mission here? Do you think there will be only one Tomcat server? Only one server? No. If you go to Flipkart, you see almost 100 missions here. How many missions you have? 100 servers. All these 100 servers will be under something called load balancer. Load balancer, LB, load balancer. How many missions you have in Flipkart? 100. Assume that 100 users. Go on mute, please. Go on mute, go on mute. Go on mute. Okay. 100 users are typing flipkart.com in their browsers. How many users? 100 users. 100 users request will come to load balancer name is flipkart.com. Flipkart.com. Okay. That means it's a mission. Okay. It's a computer. This computer name is what? Flipkart.com. When 100 users type flipkart.com, all 100 users browsers come to this flipkart.com mission, correct? There's a person sitting here. Who is that guy? Load balancer. It's again a software. You know what this load balancer will do? It will distribute different users' requests to different missions. If you have only one mission, say for example, 100 people come here. This has limited RAM, 8 GB. This has limited CPU. This has limited storage, right? So 8 GB and then say this processor, quad-core processor, for example, is not enough to execute 100 users' requests. Understand this? More people connect to your software, more processing you have to do. So more CPU, more RAM you want, right? So one mission, say 8 GB RAM is not sufficient. So what we do? We take 100 missions and then we attach all these 100 missions to something called load balancer. That means 100 missions are binded, 100 missions are attached to this load balancer. So this person know 100 missions. The moment 100 users connect to this load balancer, it will give one person's browser request to this. It will redirect another person's browser to this. So we are processing 100 users request using 100 missions in parallel. Clear with this? It's like you have 100 people to handle 100 users. Assume that 200 users are accessing application. How many missions you want? You have to add 100 more missions. So we call this as load balancing. What is that? Load balancing. When there is a more load, using this load balancer, we distribute different requests to different missions. So how many missions you see in Flipkart, for example? 100 missions. More load, more traffic, more missions you want to process. Clear with this? Or no? Any questions? So in real time, it's not only one mission. You have 100 Tomcat servers. Two people you have, Harry and then Sally. When Harry types flipkart.com, it will come to the load balancer. It will give that browser to, it will redirect that browser to this mission. Here you have the code, you have Tomcat server. This guy executes the code and sends. When Sally types Flipkart.com, it will come to load balancer. It will give that, it will redirect that browser to another machine. It is this machine which is processing this person's request. Similarly, different users' request will be processed by different missions in parallel. More load, more missions, more infrastructure you want. So if you go to Flipkart, you have how many missions? Think that you have 100 missions. Okay. Flipkart is planning for Big Billion Day. Flipkart is planning for Big Billion Day. Assume that in regular business days, Flipkart gets, say, 100 orders per minute. How many orders? 100 orders per minute. That means in a minute, Flipkart has to process 100 orders. Flipkart has to, when somebody swipes the credit card or debit card, Flipkart code has to be executed, and then it has to confirm, okay, your order is placed or not placed. So 100 orders it has to process. That's a regular, traffic they get. 100 orders per minute. OPM we say 100 orders per minute. They have 100 missions. So even if 100 users connect, so they have 100 missions, and then they can very easily serve their application. It's a big billion day, right? Big billion day means more discounts, more people access your application. So they expect 200 orders per minute during big billion day. So what they have to do, tell me? Can 100 missions handle 200 orders? For a simple math, assume that for 100 orders, you need 100 missions. For 200 orders, you need 200 missions. So what this Flipkart team does, one day before Big Billion Day, they go and then attach how many missions? 100 more missions. Totally, how many missions you have under this load balancer? 200. That means load balancer can distribute the request to 200 missions now. 100 plus 100. Correct? So,
sir, how will we know exactly we would need 100 more?
How we will know that we need exactly 100 missions? It's a different concept. It's a broad question. How we know? There are some performance evaluation tools. Using those tools, we'll see like how many missions we want, how much RAM, how much CPU you want, and things like that. And there are a lot of other strategies. For example, you can say there are some tools. Okay, if for example you have 100, okay, if 90% CPU is utilized, make sure that you add more and more missions. You just need to give 90% threshold, whatever you want. If 90% CPU is utilized, go and then add more and more missions. So it will go and then add some more missions. We can say that make sure that 50% CPU is average CPU. So there are some techniques for that. We will be learning, in fact, those things in Kubernetes too. Is that okay?
Yeah, yes, sir. Thank you.
Yeah, there are some performance evaluation tools. There are some strategies using which you can say, okay, if my RAM is 100% occupied, for example, go and then attach more and more missions so that you get more and more RAMs. There are some strategies for that. It's a lengthy story, so I'm not taking it now. But yes, you have some strategies for that. So Big Billion Day is on, right? They started receiving 100 orders per minute. They started receiving 200 orders per minute. Is there any guarantee that they won't receive 300 orders per minute? Is there any guarantee? No, right? They started receiving 300 orders per minute. Now see what happens. Do they have infrastructure to handle 300 orders per minute? No. So what Flipkart team has to do now? They have to go and attach 100 more missions. Do you have time to attach 100 missions? No. You have to take a mission, you have to install operating system, you have to install Tomcat, you have to install JDK, blah, 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 lot of things you have to do. You don't have time to scale up the environment. Scale up means adding more and more missions. Scale down means removing the missions. You don't have time to scale up your environment. As a result, what happens, Selvi? Your application will get crashed or your application will become slow. That means once user enters credit card, user has to wait 10 minutes for order confirmation. Such a bad experience you are giving to the user, correct? Because you don't have enough memory, enough CPU. So you cannot confirm the user that, okay, your order is placed. You are making user wait for 10 minutes or 20 minutes. So the bad experience, right? So why this is happening? Because we are unable to scale up. We are unable to add more and more missions dynamically. This is the problem we face in real time. You see like how DevOps tools helping any company, project, or any business. If DevOps is not there in a project, people has to go through all these consequences, right? So to solve this problem, we bring somebody called Ansible. Who is that guy? Ansible. Ansible is called as configuration management tool. Ansible is called as configuration management tool. So what is the problem here? Once we have a mission, we have to install operating system, for example, we have to install JDK, Tomcat, whatever tools are required for our application, we have to install all of them, correct? So instead of you manually installing it, so it took, say, for example, 10 days for Flipkart team to prepare 100 missions before Big Billion Day, right? Now, we don't have 10 days to add another missions, right? Another 100 missions. So what I do, I'll bring this person called Ansible. I'll tell this person, hello, Ansible, I want this version of JDK. I want this version of Tomcat. I want this, I want this, I want this, I want this. At a very high level, you write something called playbook, right? It's not a code, it's a configuration file. And then you just run this Ansible code on against this 100 missions. Ansible can go to 100 missions. It can install JDK, Tomcat, and everything in all these 100 missions. And it can prepare 100 missions in few minutes for you. Like Maven is compiling thousands of .java files. Here, Ansible is installing tools or softwares, whatever is required for your application. So using Ansible, what we are doing, we're able to automate application configuration, that means installations.
All the existing tools.
They're all existing tools, yeah. So Ansible is called as application configuration management tool. If you want to configure an application, that means if you want to install something, right, you do that using Ansible. You call this code as playbook. Playbook. That means whatever you need, just write everything in something called YAML format, YAML. Like it's not like a Java, it's a simple configuration file. And then this will go and then you just execute it, and then it can prepare 100 missions in a few minutes for you. And then you add 100 missions and you're able to serve 300 hours per minute very easily. Understand what is Ansible? For example, let me simplify it. For example, I have this lab, okay? I have 20 computers in my lab. 20 computers for 20 students. Suddenly, I get 100 students. What I have to do? I have to prepare 80 more missions, right? If I have to prepare one mission manually, right, it will take 2 hours for me, for example. For 80 computers, because whatever tools are required for my DevOps student, I have to install and keep ready, right? So if I do manually, it will take 2 days, 3 days for me. Instead of doing what I do, what I can do, I just write this Ansible playbook. I say, I want this, I want this, I want this in a mission. And then I just execute it in, say, 80 missions. So this will go then install everything for me automatically in 80 missions. I can now configure, I can install everything in 80 missions within a few minutes or hours. That's called automation, right? Okay. So Ansible is called as configuration management tool. Writing this code, this code where whatever you have is called as a playbook. Ansible. Ansible role is like you have a lot of missions, right? So you write the code and then you use the same code in multiple places. That's a different thing. It's a pure technical. I can answer that offline. Since you already have some idea, you're asking about Ansible too. Okay. Fine. In order to apply Ansible, you need to have 100 missions first, right? You need to have 100 missions first, right? First, you need to have 100 missions. That's hardware, operating system. Then only you can apply Ansible, correct? So from where these 100 missions come? So you know what Flipkart does? Let's say before Big Billion Day, they purchase 100 missions. They purchase 100 missions hardware. They purchase 200 missions, for example. Again, if they get 400 hours per minute, again they need 100 missions, right? Correct? Assume that they have purchased some missions before Big Billion Day, thinking, okay, they need that. Next day, do you need these 200 missions next day after big billion day? No, right? Your traffic will fall back to 100 orders per minute after big billion day, right? That's a regular business hours. So just for one day, you have purchased 200 missions or 500 missions. Until next big billion day happens, you don't need these missions. So what you have to do? You have to buy a space. You have to keep these 200, 300 missions in some place, right? You have to pay for rent, real estate cost. You have to buy some racks. You have to buy some plugs, AC, and a lot of investment you have to do. Correct? And you need to have some people to manage or maintain those missions. If you see down the line after a year, your maintenance cost will be double than purchase cost. Correct? So it's not a good idea to purchase the missions. Instead, you know what I do? I don't purchase the missions, right? Instead, I just look up the cloud. Take the real meaning of cloud, right? I just look up the cloud and then say, hello cloud, I want 100 missions. Can you please give? It will say, yes, these are the 100 missions. Hello cloud, I want 100 more missions. Cloud will just throw 100 missions. What if cloud will give you 100 missions? And cloud will say, I'll give you 100 missions. For how many days? I said 24 hours. Cloud will say, 24 hours, if you are using 100 missions, you pay this much to me. And once your task is done, you return my missions, you don't need to pay. Pay for what you use. So that cloud is AWS, Azure, or Google Cloud. That's their business. If you go to Amazon, right? Amazon company, they have huge infrastructure in their data centers. They say, whenever you want 100 missions, don't purchase, just come to us. We will give you 100 missions and you pay for what you use. You call that as infrastructure as a service, IaaS. What is that? Infrastructure as a service. When you want some infrastructure, don't purchase, come to us, take our service, pay for what you use. That is called as a service. That's where we use cloud, correct? I'll give you a simple example. You have a function in your family. You expect, some guests. Do you purchase extra tables, chairs, all the stuff for one day, 2 days? No, right? What do? We go to a shop, we take on rent, we pay for what we use. 1 day something, 2 days something, 3 days something. What if you purchase? You have to again buy a 2 BHK, 3 BHK to store all those items, and you see the cost. Until next function happens, you have to maintain these things. Is it possible for us? Very difficult, right? So same thing here. When you want some infrastructure, go to the cloud, pay for what you use. Pay as you go. That's the thing. That's where we use cloud, any cloud for that matter, in DevOps. DevOps is different. Cloud is different. These days, people call something like the AWS DevOps, Azure DevOps, GCP DevOps, and things like that. Whatever we are learning here, that is AWS DevOps. What is AWS DevOps? And that's very popular. So this is you, DevOps engineer. If your project is using cloud, then only you need to know cloud, correct? So as a DevOps engineer, if you are using missions from DevOps, as a DevOps, you should know how to create a new mission in cloud, right? How to configure, how to deploy the bar file into that mission and things like that. So for that reason, we learn AWS. We learn AWS, whatever is required for us. Whatever services are required for us, we learn only that. We are not cloud engineers. If you want to pursue your career, if you want to settle in the cloud, AWS DevOps is not right course for you. You have to take AWS Associate Solution Architect course. These guys are experts in cloud. They're like pure cloud experts. We are DevOps engineers. So whatever is required for us, we learn only that AWS, and we spent almost 8 to 10 hours on AWS. That is more than enough for us. So if you have knowledge in AWS plus DevOps, it will improve the chances of getting the job. It will improve your salaries and things like that. Most of the companies today are using, the projects are using some cloud. Mostly AWS is very popular. So it's a AWS DevOps. Understand the difference between AWS and DevOps, right? So when it comes to big billion day, what we do, when we want to add more and more missions, if you want to add 100 servers, first you need to create 100 missions from the cloud. Then you apply Ansible. Ansible will install everything. Correct. Now you tell me. Again, there is a manual activity here, right? Is it possible? So dynamically we have to do, right? When you get 100 extra orders suddenly, you have to automatically go create 100 missions, apply Ansible. So who will create 100 missions again? Again, there is a manual activity, right? So you have to create a mission, install operating system. You have to, some missions you want RAM, 8 GB RAM. In some missions you want 16 GB RAM, all the stuff. Who will create the missions? That's where I bring another person called Terraform. Again, you just give some information to Terraform. Hello, Terraform. I want a mission with this operating system, with this RAM, with this CPU, with this storage, and things like that. Terraform will create 100 missions. See, Terraform is called as infrastructure provisioning tool. Provisioning means creating something. Infrastructure means the missions, right? So Terraform is called as infrastructure provisioning tool. So when you want to add 100 missions, you first go to Terraform. Hello, Terraform. Please create 100 missions. It will quickly go to your AWS code. It will create 100 missions with some operating system. Then you apply Ansible. Ansible will install everything for and then you have 100 servers ready. So Terraform is infrastructure provisioning tool. Ansible is application configuration, installations, and things like that. And AWS, it's a cloud where you can provision the things whatever you want, and you pay for what you use. Clear with these three tools? This is your Terraform, AWS, Ansible. Any questions here so far?
Sir, can you again explain what's Terraform, sir?
So it's a big billion day. Big billion day is on. I have 100 servers. I'm able to happily serve 100 orders per minute. I got 200 servers, right? I have 200 servers. Sorry, 200 orders. I have 200 servers. Suddenly, I got 300 more. Suddenly I'm receiving 300 orders per minute. So I want to add 100 missions, correct? 100 extra, correct? So you need to first create 100 missions having some operating system. So we go to this person called Terraform. In Terraform, we read something called TF file, Terraform file. Just execute the file. Terraform will go to the cloud. It will create 100 missions first. 100 missions you have with some operating system. So that's the job of Terraform, infrastructure provisioning tool. Provisioning means creating, infrastructure creation tool. Once you create the missions, then you apply Ansible. Ansible will install all required softwares, and your machine is ready to serve the application. Understand that?
Yes, sir.
Okay. That's Terraform, AWS, and Ansible. Should I continue for another 10 minutes? Or should we stop?
Continue.
If you want to know what is Docker, I can try to explain. See, anyway, you'll be learning all these things in DevOps tasks. Okay, since let's not leave it in the middle. Okay, let me explain what is Docker and Kubernetes quickly. Okay, just give me another 5 minutes. I'll try to reduce the time. Okay, okay. Because I see people leaving from last 2 to 3 minutes because it's very late, I guess. Okay, see this. Forget about whatever we discussed so far. This is your hardware. You have some operating system. You have a computer. Okay. You have a computer. You have 8 GB RAM. You have, say, octa-core CPU, some CPU. You have 500 GB. You have 500 GB hard disk drive, HDD. This is your hardware. You have a computer. 8 GB RAM, 8 GB, sorry, octa-core CPU, 8C octa-core CPU, 500 GB hard disk. You have installed operating system on top of your hardware, and then you are running some application. You are using this laptop. Okay. This is your friend. Your friend also has some hardware, operating system. Your friend also has a computer. Your friend is working on some, application. Your friend needs another laptop. Your friend wants to, like, assume that he's developing some application and he wants to run his application on another machine. So this guy has to buy another machine, correct? Another laptop or desktop he has to buy. Instead of buying, this person comes to you, says, I want a machine. Can I use your desktop or laptop? You say, this is my laptop. I also need it. I cannot give my laptop to you. Go and purchase. So your friend says, okay, that's fine. But tell me how much RAM you have. You say 8 GB. How much CPU you have? Octa-core. How much hard disk you have? 500 GB hard disk. Your friend asks, are you using 8 GB RAM, octa-core CPU, and then 500 GB hard disk? You say, no, I'm not using. Then can I borrow unused hardware? That's a question from your friend. I say, I cannot share my hardware to you. Your friend's idea is, you're not using RAM, right? He wants to take the unused RAM, CPU, and then he wants to install operating system. He wants to run something. So can you share the hardware with other machines from your laptop? No, right? You have 1 TB hard disk in your laptop. You want to run something in separate machine. Can you share this 1 TB to another machine? No, right? Can you share RAM, CPU, hard disk to another laptop? No, right? Once it is attached to one machine, it is only for that. No matter whether you use that RAM or CPU or storage, it is only for that machine. See the problem that we have. Are you using the hardware to its max capacity? No, right? So this is the problem we face these days. You have invested a lot of money, right? When you want another machine, you have to go and then purchase again hardware, and then you have to install operating system and then do it. So this is the problem with desktop machines. So your friend has to buy another laptop in this case, correct? Because you cannot share unused hardware. As technology evolves, we came up with something called virtualization. What is it? Virtualization. TIOL. You know what we can do using this virtualization? So you have RAM, you have CPU, you have hard disk drive. Okay. Using this virtualization technology, you can create multiple machines. You know what this technology will do? It's again a software. Okay. This will give same RAM, CPU, hard disk to it. Same RAM, CPU, hard disk. Same RAM, CPU to this machine. That means using this virtualization technology, you are able to virtualize the hardware, correct? That means virtualization means which is not present physically. Even though these machines don't have RAM, CPU, hard disk, you are supplying the same RAM, CPU, hard disk from this machine, correct? So I'll take that question later. So this virtualization technology is helping us to share the hardware. So here you are able to efficiently utilize your hardware, correct? Now, since you have virtualization technology, your friend comes to you and says, I want a mission. What you can do? You can just create another mission for him, and then your friend can go and run the application. So that way you are, utilizing the hardware efficiently. So that is the advantage of virtualization technology. So on top of this hardware, you install some operating system, and then you can run your application 1 here, application 2 here, application 3 here. So using virtualization technology, you can share the hardware. That way you can efficiently utilize your hardware. Clear? If you are creating a mission using this virtualization technology, you call that as VM, virtual mission 1, virtual mission 2. Similarly, you can create n number of virtual missions, VMN. Any number of virtual missions you can create. Virtualization technology is great even today, but people are moving from something called virtualization to Dockerization or containerization. What is that? See it? This is your RAM CPU, this is your OS, this is your, say, Docker. For example, take the same example, okay? You have some RAM, you have some CPU, you have some hard disk drive, you have some operating system. Here, I'll bring something called Docker. This guy. Docker. Using Docker also, you can create any number of missions. Docker also can virtualize the hardware. That means Docker also will give same RAM, CPU, hard disk to all these machines. Like virtualization, Docker is also doing the same thing, correct? Right? So when Docker is doing the same thing, here we have virtualization, here we have Docker software. So when Docker is also doing the same thing, what is the difference between two? That's a question, right? Why people are moving from virtualization technology to Dockerization technology? Why? If you are creating a machine using Docker, you call it as container. Container 1, container 2, container 3. Container means a mission. Virtual machine means it's a mission. It's a computer. If you see here, each and every operating system, each and every virtual machine has a dedicated operating system, correct? You have operating system installation in this virtual machine. In all these 3 virtual machines, you have operating system installation. Operating system installation is almost 3 GB. That means 3 GB code is sitting in each and every machine. 3 GB code means it's a software, right? So it also requires some RAM CPU, correct? You buy 64 GB mobile. Do you get 64 GB? You get 60 or 62. Where is remaining hardware? That's occupied by your operating system, right? So by having operating system in each and every machine, you are wasting a lot of hardware again. See the problem of virtualization technology. If you go to the Docker, what happens? You don't need to install operating system. You don't need to install operating system. Here you have to install operating system. Here you don't need to install operating system. That means 3 GB code is not sitting in each and every machine. You know what Docker does? Docker virtualizes the hardware as well as operating system also. Without you installing 3 GB code, right? Docker can create operating system kind of environment virtually for you. That's a technology. We will discuss that later, right? It's a demo class, right? Just think that without you installing 3 GB operating system code, Docker can create operating system kind of environment virtually for you. Then you run your application 1, application 2, application 3 here. What is the difference between virtualization and then Dockerization? In virtualization, you have operating system installation. Here you don't have 3 GB code setting. Since there is no code, since there is no operating system in Docker, it takes less RAM CPU, correct? Assume that you have 8 GB RAM, octa-core processor, 500 GB hard disk. You can create, say, 4 virtual machines. With the same configuration here, you can create 40 missions. 4 missions versus 40 missions because there is no operating system. So you can create more and more missions on top of less hardware. See that mechanism, correct? So it will take more time to create a virtual machine, correct? If you want to create a virtual machine, it will take more time. Why? Because you have to install operating system. If you want to install operating system, it will take 3-4 minutes. Think those big billion days kind of days where you have to go and then add more and more missions. Do you have time to spend 3-4 minutes to install operating system? No, right? It's very difficult. So it will take more time to create a mission, virtual mission. It will take more time to start a virtual mission. Why? Because the moment you switch on the power, your laptop, you'll have to wait for 2-3 minutes, right? What's happening there? Your operating system is loading. Since there is an operating system, it will take more time to start a mission. It will take more time to stop a mission because operating system has to go down. And it is heavy. Heavy means it will take more hardware because 3 GB operating system code is sitting. If you go to Docker, it will take very less time to create a mission. In fact, you can create a container within less than a second. Within less than a second, your mission is ready. So you can add more and more missions during big billion days very fast. Why how you are able to create a mission within less than a second? Because you are not able to, you don't need to install operating system, right? So you can create a mission within less than a second. It will take less time to start because there is no operating system. It will take less time to stop a mission, and it is lightweight, right? If you can create 4 machines here using Docker, you can create 40 machines because operating system is virtualized and there is no physical copy of the operating system in these machines. See the advantage of Docker now. Where we apply Docker here. We have these machines, right? Correct? These machines can be desktop. You cannot share the hardware. These machines can be VMs. These machines can be containers, like that means Docker containers. So if it's a Docker container, you can create the machines very fast. Start is very fast. Stop is very fast. And these are lightweight. When using less hardware, you can create more and more machines. So in your project, in your company, if you have machines which are created using Docker, you should know how to create a machine using Docker, how to create a container using Docker, how to start it, how to stop it, how to deploy the warfare to that and things like that. So that's where Docker helps us to minimize the cost of infrastructure. That's again trending technology, Docker. Correct. See, if a Flipkart company adopts these tools, implements these tools, right? How they save a lot of money, correct? How quickly they can deploy the code, how efficiently they can serve their application to their customers and things like that. That's about Docker. It's a containerization tool. What is Kubernetes? In 2 minutes, see this. Assume that you have containers. You have created the machines using Docker, 100 machines, right? Assume that for Flipkart, you always need 100 machines. What if 10 goes down? You have only 90 machines. 90 means application is slow. Ideally, typically in software, what we do, we have a monitoring system. Somebody, you will get the alert. Somebody will go. Somebody has to create 10 more machines again. Gone the days where you get the alert. Somebody will go repair the system. No. These days, what we do? We aim for something called self-healing. What is that? Self-healing means if there is a problem in your system, the system will automatically repair on its own. Means if 10 machines go down, 10 machines should be automatically created for you. If you want to automate it, very difficult for you. That's where we bring somebody called Kubernetes. You just need to tell Kubernetes, hello Kubernetes, I want 100 machines. If 10 goes down, Kubernetes will automatically add 10 more machines for us. Kubernetes is again another tool. Correct? Assume that somebody asked, right? How do you automate? How do you know how many machines you have to add? How many machines you have to add? You just tell Kubernetes, hello Kubernetes, if CPU goes beyond 90%, go and then add more and more machines. Kubernetes can automatically auto-scale for us. Means if there is more load, Kubernetes can automatically add more machines. If there is less load, it will automatically remove the machines. Because if these machines are taken from cloud, you have to return it back, right? If you're using, you have to pay, right? So Kubernetes can automatically scale up, scale down environment for us. Since Kubernetes is helping us with self-healing and then, auto-scaling and things like that, we call this as container management tool or orchestration tool. If there's a Docker, Kubernetes is there. Kubernetes can help us with all these things. There are a lot of other advantages. Since we don't have time, I'm just stopping it. So understand what is Kubernetes?
Yes, sir.
Kubernetes is container management tool. Docker container management tool, or you call it as orchestration tool. Clear with that? Okay. Just give me another minute. Okay. That's about the tools we have. So as I mentioned, you don't need to know anything. I don't expect anything from you. Okay. More empty minded you are, more easy for me to train you. Okay. People who are working in non-technical stuff, for example, people who are from the non-computer science background, people who passed out 2018, 19, 17 and things like that, you come to me. I can first train you on DevOps from very basics to the advanced level, right? This is the first thing. If you need any documentation support, I can give you, right? I have some referrals. I can point you to the right person. So training, documentation support. Once the training is done, I'll help you with the resume preparation. Right? The big task here is to prepare the resume with the real-time projects, fine-tuning or creating your Naukri profile and things like that. So that resume support and everything is there. While you start giving the interviews, I'll also help you with interview questions. Best thing is, if you are taking offline, you can come to my institute, Marathon Bangalore. You can sit here whole day, you can practice. Right? This is the thing. Assume that the course duration is 2.5 to 3 months. Course price is 25,000, 2.5 to 3 months. There's another thing. There are a lot of other players in the market who train DevOps with say 40 to 45 hours in 40, 45 hours. These many tools in 40, 45 hours. Is it possible to learn from scratch? Advanced? Hardly you will get 2-3 hours. In 2-3 hours, you cannot learn Jenkins. 2-3 hours, you cannot learn Docker. No. Here in Vikalti, I spend almost 100 plus hours. 100 plus hours. So minimum we spend 10 to 13 hours on one tool. That's how we learn. Okay. So it's a very extensive, very advanced. And training and then resume preparation, things like that. You can give interviews on your own. For some reason, if you are unable to crack the interviews, come to me. I can give you 100% placements, provided you have practiced at least 50-60% of, you have 50-60% of knowledge. How do I give 100% placements? That's a question, right? Because everybody claims that 100% placements. Right? I have a lot of clients, right, tied up with me. And once you are for the placement, right, I'll again give you some, a training and stuff like that. And then I have some reference, right? I'll refer you to my clients and then I can assure 100% placement. If you are opting for 100% placement, you need to pay 3 months salary. How much? 3 months salary. You can pay this 3 months salary in 6 EMIs. That means 6 months only after getting your salary. If you're not getting the salary, don't pay me anything. Okay. So once I place you, 3 months salary, you can pay in 6 EMIs. That means half you take, half you give me 6 months. For some reason, if you lost the job, come back to me. I'll again place you in other place. I have different ways to do it. Okay. Forget about the placement. If you have some referrals, if somebody is helping you to, if somebody is helping you with the placement, you can happily go with them. People also take 2 months salary, 1 month salary, they place you, right? You can go to them. I charge 3 months for my service because the package that I get and things like that. Go to other places for placements. I'm perfectly fine, but don't go to other places for learning, because that's my confidence, right? Because whatever you learn here, I can 100% tell you that you get knowledge which is equal to 3-4 years of real-time experience. Placements, if you find some cheaper solutions and then give the best service, you can go to them. But for course, at least don't go to other places. Vikalti is the best. I can promise that to you, because learning is very important. If you have stuff, if you're technically strong, you can crack the interview on your own, and then you can survive in real time very easily. Not just placement. After placement, if you need any job support, I can also give that to you. Say you have joined with some experience, for example, right? You are unable to perform some tasks. Come to me, right? I have my old students who have 4, 5, 6 real-time experience. Those people come to you and then they will help you. They take something and then they will help you in real-time projects. After placement also, I can help you with training, resume preparation, things like that. Placement after job help also. Okay, we call that as what? Job service, whatever. So these are the things that services that I provide. You can note down my number. It's 97393-68768. My name is Nageshwar Rao. This is my WhatsApp as well. Okay, forgot to tell you. I'm I have almost 10 years of experience in helping people to transition the career to IT field in DevOps. I have a lot of other courses also, but people who have gaps, DevOps is the best. Why I tell this? Because when you want to get into IT, you need to take 3 parameters into account. I always say this. First thing, whatever course that you choose, that should have good demand in the market, correct? Assume that you go and then learn, say, data sets. Sorry, you go and then learn testing, for example. There are thousands, lakhs of people outside who are waiting for jobs in testing. There is no demand. So you learn a course that doesn't have demand. What is the use? If you are not getting the calls, no use. So you have to learn the course. You have to select the course which has good demand in the market. DevOps has a very good demand. Data science, Python, Java, full stack. These are all demanded courses. But DevOps is the best. Why? Because you put the second parameter. First parameter, you select the course. You have to select the course which has good demand in the market. Second thing, you have to select the course which is easy for you to learn. For example, you have 3-4 years gap. You learn Python, Java. These two are, yes, demanded tools, demanded technologies, but it should be easy for you to learn, right? If something is not easy, no matter if it has a demand, you cannot crack the interview. That won't help you. But DevOps is very easy compared to Python, Java, and data science and things like that. So DevOps has a good demand in the market. DevOps is easy to learn. Third parameter, you should be able to survive in real time, for a long time. Third question is, will I be able to survive in industry for a long time with this course? Will I be able to survive long term with a good salary, for example? DevOps, as I said, as long as there is a software, DevOps is required. If you see this, correct? Compilation, scale up, scale down, these things are required, right? As long as there is a software. So DevOps has a very good demand. It's very easy to learn. You can survive in real time very easily for a longer time. For example, you take tab, you click, you kind of some tools. If the tool goes down in the market, you are nowhere in the market. You have to again come to this kind of institutes, and you have to again learn new tools. DevOps is not that. It will be there forever as long as there is a software. So if you compare, if you take all these parameters into mind, DevOps is the best for people who are trying to get into IT. I have a lot of other courses like Python, Java, and things like that. But people who have gaps, who want to get into IT from non-technical domain, please take DevOps. That's my 10 years of experience in training industry and 17 years of experience in software. There may be other, courses, 1 or 2, but this is the best, is what I can say based on my experience. Yeah. And if you want to email me, you can take this. This is my email address, nageswara.rao @yculty.com, WICULTY.com. You can also follow me in LinkedIn with the same email ID. Just type this, you can find me. What I'll do now, one second. I'll stop the demo session. 1 second. This is demo come first class. Okay. We'll continue next class tomorrow. And if you have any questions, say for example, if you have any career related questions, go on mute, please. I'll take your question. Please go on mute.
Sir, I just want to know what.
1 second, please. 1 second. Go on mute. I'll give you a chance. So since it's too late now, what I'll do, you take my number, call me tomorrow after 2 p.m. If you have any career related, if you need any career related guidance, say, I'm working here, I want to get into IT, this is my degree background, this is what I have done, and anything it is, right? Call me, I can guide you. Right? You can also call me now if you are okay on this number, I can talk to you. Better you call me tomorrow, but if you have something urgent, you can call me even now as well. Okay. So Go ahead with your questions. If I can answer quickly, I'll take it. Otherwise, I'll take it offline. That means after the session.
Okay.
Questions?
Excuse me, sir. How many classes are there in a week?
In a week, I target for 6 to 8 hours. 4 days a week. 4 days a week.
Means from Monday, sir?
Tuesday to Friday. Sometimes I take on Friday also. Fridays.
So Tuesday, Wednesday, Thursday, Friday.
Yeah. So people are asking, what is the minimum salary I get in DevOps? I'll tell you a simple formula for that. Assume that you have 3 years experience. You are claiming 3 years experience. Say 3.5. 3 into 3.5. 10.5, right? 3 into 3, 9. 9 to 10.5. You're claiming 4 years experience. 4 years into 3.5, how much? 14 lakhs package. 4 into 3, 12. 12 to 14 lakhs package. If you are claiming 4 years, 12 to 14 lakhs, 3 years, maybe 9 to 10.5. Somewhere around that you can expect. Again, salary depends on a lot of parameters. What company you are joining, how much you have practiced, right? How many tools you have expertise in, and a lot of other things, market, situations, and a lot of things. But this is like ideal thing. Your experience into 3. Yeah. This is minimum. It can go up to experience into 4.5 also. Right. Right. Any other questions you have?
Bro, tell about the opportunities for internships or freshers, how the freshers are welcoming in this field.
I have my own software company, a startup. After completion of the DevOps, if you want to work as an internship, you can come and then work in my own company. I can give you internship certificate for 6 months or 3 months, whatever you do, and you can try jobs outside. Or if you are good, I only absorb you. I only hire you. If I have openings in my company, I can give you internship certificate as well. Okay. Any other questions?
Yeah, okay.
you have?
Yeah.
Right. Thanks for joining. Thanks for staying late. We should have started demo maybe a little early, 7 o'clock. That's a.
So those who have gaps, will they able
Sorry?
to? So those who have gaps like 1 to 2 years, so how will they adjust in this field?
Can you please call me? I'll talk
Sure,
to you.
sure.
Just call me after 5-10 minutes, okay? Since it's too late, let's wait off. I don't want people to wait. Okay, thanks for joining. Thanks for staying late.
Good.
Thank you, sir. Thank you so much.
Thank you very much. Good night.
Thank you.
Thank you, sir. Thank you.